Now demulsifier, now you have emulsifying agent, so your particles are not getting bigger, so your Vt is becoming smaller because of small d. Alright. Now you want to remove this one and you want to make bigger d. So diameter should be bigger, so particle settlement maybe water particle, bigger water particle will fall down quickly, bigger oil particle will be moving up quickly if it is in water. Okay. So demulsifier also chemical. Okay. These chemicals, for example, polypropylene oxide, some example. Polypropylene oxides, ethoxylated phenol, okay, some examples you should remember. Okay. Polyhydric alcohol, now some simple names are there like benzene, xylene, then short chain alcohol, cohols. Okay, these are some examples of demulsifier. How it is happening? Let's say you have oil water mixture. Okay, then one will be creaming will be there, sedimentation, and flocculation. So how creaming is happening? If you have oil particle in water, so oil particle will try to float over water. Flocculation, it will be like this, particle will be joining somewhere, okay, like this. The sedimentation means it is just opposite of creaming, so particle will be like water in oil, so particle will be trying to settle the bottom. Okay. So altogether what they are doing, initially when particle are agglomerating or coming together nearby, so they will try to touch each other. Okay. When if they are touching like this, so slowly what will make like this, then it will make bigger particle. Okay. So sequentially it will happen. So lots of particle coming together, so it is there is a high chance that the particle will be colliding each other. When they are colliding, that they will try to make bigger particle. Okay. So then you got bigger particle, your dm increased, you are happy. Okay. So three things they say like creaming, flocculation, sedimentation. Okay, whenever you are talking about coalescence, actually two particle mixing together and making bigger particle. Okay. And they are making bigger particle. So coalescing, joining, agglomerating. Okay. They have some formula like T equals pi by 6 d power j d naught power j phi k s. So this formula is taken from your book Arnold and Morris. Okay. Arnold and Morris. Surface production operation. Okay. This book. And DO is the initial droplet size, DJ is the final. Okay. J is the empirical parameter. Empirical parameter for particular system, Okay. Ks also empirical parameter. Okay. J value normally it will be more than 3, and phi is the volume fraction. And T is the time to grow. a particle or time to grow droplet size. Okay, so this formula. So if you have higher volume fraction, so quickly it will be settling. So volume fraction means like large number of particles are there. That means it is a high chance that they will be colliding each other very quickly. Okay. Now this says like if you have J value 4, so in that case formula is getting changed like this. So J power will be this, and if DO initial particle size is very small, so they are approximating this one. Initial particle size is very small. Okay, and approximating pi they are taking around 3, so pi by 6 becoming almost half. Okay, so that's why this formula is like this: T equals half d power 4, because d0 is d naught ignored, and phi case. Okay, so that way they derive the formula. Okay, now if you can make coalescence means making two particle bigger. Okay, and that bigger particle means you can use your any technique to make bigger particle. Okay, so if you are increasing temperature, actually you are changing viscosity also. Okay, with temperature how viscosity changes? Mu is viscosity. Okay, so heavy crude and other crude like light crude. So in all cases you can see viscosity changing. Okay, viscosity reducing. When if viscosity means resistance to flow, right? If something is trying to move, viscosity means is pulling back. So viscosity going down means that pulling back force is lower. Okay, so increased temperature, pulling back force is lower, so settlement rate will be quicker. Okay, whatever particle size is there, if your bigger particle size is good, if you have smaller particle size also, viscosity change means your resistance force is changed. Resistance change means quicker. So Vt you can remember, okay, inversely proportional. So terminal velocity or particle movement velocity will be quicker. Viscosity changed. Viscosity why change? Because you change temperature. How you are changing temperature? You will have some heating mechanism. Okay, using that one you are changing temperature, then viscosity changing. Normally this heavy oil, API gravity will be like around 10. Okay, if some API gravity, if API gravity is 10, it is actually same gravity as water. Okay, if less than 10, then the oil will be sinking in water. If you more than 10, then oil will be floating actually. Okay, so this relationship is just opposite. Okay, and API, what is API? API actually API gravity equals 141.5 divided by Sg minus 131.5. Okay, you should remember the formula, because every time you say API gravity, but if you are given Sg specific gravity, then you can convert to API gravity. Now here you can see if I put Sg equals 1, it is become 10. If right, so if some oil is having 10 specific gravity, that means it is equal to same gravity as water. Okay, it will not flow, neither float, not it will be sinking. Okay. So phase inversion, one term will be coming actually, water cut. This term, water cut means how much percentage of water there in oil. Okay, let's say 0% water cut means there is no water, 100% water cut means there is no oil. Okay, so water cut means percentage of water there in oil. And if I draw water cut 0, 100 water cut, so viscosity, apparent viscosity will be like this. Okay, around 70%, the viscosity will be very high. Okay, this is called phase inversion area. Okay, when viscosity is suddenly changing, that portion called phase inversion. So in that case, what is happening? Initially, low amount of water is there in oil. So that is water in oil. This is water in oil area. Okay, but oil percentage increased. So in that case, this area, oil in water. Okay, so now you got more water, less oil. So it become oil is there in water. So oil in water emulsion. So emulsion changed water in oil to oil in water. So the changing the point is called phase inversion point. So knowing this one is important, because whenever you are trying to calculate fluid flow through any pipe or any settlement or anything, so there you have to know the viscosity, okay, and water cut also. If water cut changing, your viscosity will change. When viscosity changing, viscosity relevant to your fluid friction actually. You can remember fluid friction, or you can see the formula also directly, Vt, right. Viscosity can change if you have emulsion, right. And if you have pressure drop formula, you can remember FLV square by 2 GD flowing through pipe, friction factor, length of pipe, velocity of fluid, GD. So F will be coming with viscosity. F is friction factor. Friction factor is linked with viscosity. How is linked? Friction factor linked to Reynolds number. Reynolds number linked to viscosity. Okay, so viscosity will give Reynolds number will give friction factor. Then you are calculating pressure drop. So your phase inversion or water cut percentage is playing a role there. Okay, so water cut changing, viscosity changing, Reynolds number changing, friction factor changing your pressure drop. Okay, so you create certain pumping mechanism, and you have longer pipe, and if you do not check the viscosity, then although you have pump everything arranged, finally you will find low pressure. Okay, your target pressure is not getting reached because you did not consider the water cut percentage maybe. Okay, so that portion also you have to consider. Temperature. So temperature changes viscosity. Temperature changes viscosity. Okay, viscosity already told, and loss of volume, because loss of volatile component will go. Okay, because of that volume will be lost from liquid. So loss of volume. Loss of volume, LOSS, loss of volume will be there. Okay, because low boiling point hydrocarbon will go off. Loss of income, as gas will contain liquid. Okay, so you increase temperature, so some liquid gone to gas line, so your income will be lower. In oil, when you are selling, so some oil is already gone. Okay, so you have to check that one also whenever heating for your viscosity changing. Okay, so temperature and loss of volume curve will be like this. So you increase more temperature, your volume loss will be more. Okay, and temperature will change your density also. This is not time, this is temperature. Okay, so density, it will reduce, because of temperature the volume will be expanding, right. Fluid will be expanding. Why expanding? Because molecular resonance will increase. Okay, if gas is there, gas particle, the Bernoulli motion will be increasing, and if it is liquid, in liquid case the particle resonance will increase. So because of resonance, it will take little larger volume, and it is a larger volume, density reduced. Okay, the smaller volume is density high, larger volume density low. So increased temperature, resonance increase, that's why volume changed. Yeah, volume change and density change. You want to go? Okay, then a small portion are there. I'll complete. Okay, I don't have much more slide. I think 2-3 slides are there. 3-4 slides are there. Maybe 10-20 minutes. I'll. Okay, leave, then I'll complete this one. Okay, increasing temperature will change your viscosity. So when you are increasing temperature of oil and gas mixture or oil only, So in that case, how much heat you have to put? Just try to get this formula. So this formula is like Q15 Q oil del T 0.5 Sg of oil, specific gravity of oil, okay, plus 0.1. This is the formula. Okay, so this will be 16. This is flow rate. QO is oil flow rate. QO is oil flow rate. This unit is BOPD. BOPD. Here you can see I am writing BOPD. I can write BPD or B by D. Someone will write in small letter also. So many type of forms are there, but meaning is same, barrel of oil per day. Okay, someone will write B by D or small, all small in BPD or BOPD. Okay, Q, small q is BTU, heat required, British thermal unit, divided by per hour. Okay, and del T is degree Fahrenheit units. So whenever you are calculating, you should know the unit. So that's why I am giving all the units. And we are assuming less than 10% water is there. Less than 10% water is there. Very small amount of water is there. And general heat transfer equation. This is general heat transfer equation. So C is heat capacity. Heat capacity. C is heat capacity, and the unit is BTU divided by pound degree Fahrenheit, and mass LB per hour, and del T degree Fahrenheit. So if we convert the unit, we will be getting like this, 350 by 24, because water weight W equals 350 by 24 SGL QL liquid. So QL is BPD. Okay, and so Q is coming oil, heat for oil, heat for water, and some amount of heat will be lost. So altogether is becoming like 350 by 24 Sg oil plus oil flow rate, Sg water plus water flow rate, delta temperature. Okay, coalescing media. Coalescing is that you are making smaller particle to bigger particle. Okay, two or more particle will be combining together and you are making bigger particle. So one way is that electric method you are using chemical method, or using mechanical method, or many other method you can use, and you can make bigger particle. Okay, or you can give longer time also, so that you can make bigger particle and particle will be settling because of the formula Vt proportional dm square. Okay, now how to do the mechanical separation mechanism? Mechanical separation is like this. Let's say I have one layer here, and fluid is entering here, exiting here. Okay, and lots of oil particle is here. Okay, when fluid is moving up slowly, very laminar flow you create, laminar flow. Okay, so what will happen? Because of laminar flow, oil particle slowly it will create one layer here on the top. Okay, so when oil particle creating layer, so two particle will create bigger particle, because they are very much closer now. When they are creating bigger particle, so oil particle slowly can move up. Okay, and water particle can go out, and we can create haze section. Okay, so that way we can create some section like this, wavy section, and we can give lots of surface area, and the particle will be colliding each other, and we can create laminar flow. So that flow will create bigger particle and it will be getting settled. So media also very important where you are settling. So if you are taking very big particle are distant far away, or whatever method you use, your detention time will be longer. So in oil industry, what they will do, they will create very thin section, and through thin section they will try to pass your fluid. So when fluid is passing through the thin section, there is greater chance that small particle will be colliding each other. When colliding each other, they will try to make bigger particle. So bigger particle means quicker settlement, maybe water or oil, doesn't matter. Common mechanical means it will be promoting coalescence, providing large surface area, and maybe common wood related coalescing media you can create, common wood or hay section you can create, and you create resistance to flow, or you create very laminar, very small thin section for laminar flow, so that particle will be colliding and it will be creating big particle. Okay, so it promotes collisions, collision. Okay. Electrostatic coalescence. Using electrical means actually you are trying to create larger particle. Okay, you are not changing viscosity or density or anything. You are just trying to create larger particle, so that Vt proportional to dm square. So Vt will be larger because of creating bigger particle. And how to create bigger particle? So I have one electrode. Let's say this is positive, this is negative electrode. Okay, now I put in an emulsion where polarized water particles are there, for example, and because of electric charge you are giving, very high voltage you are creating, because of high voltage this will be creating negative plus minus plus minus plus. Okay, so particle will be getting polarized, and when it is getting polarized, so negative end or negative polar pole of the water particle will be attracted towards positive pole. Okay, so here negative pole, negative electrode is here, so my positive side will be moving here. So what will happen finally? My electrode will have lots of fluid nearby, particle nearby. Okay, when particles are nearby, they will try to collide each other, they will try to make a bigger particle, they will get separated. So one formula is here, taken from again K. Arnold and Morris book. Attractive force, this is attractive force. Attractive force, Ks is the constant for a system. S4 is the difference between droplets, distance between droplets. Distance between droplet, and epsilon is voltage, how much voltage you are giving, voltage gradient, and dm is the particle size, or droplet size, droplet or particle, whatever you say, particle size. Okay, now if you have larger particle, so force will be larger, distance is larger. If you say S, if very large, then force will be lower. Okay, so particles are long distance, that means force will be very weak. Particles very closer, force will be very high, so they will be colliding each other quickly. So it will be working in three ways. One will be that droplet will be polarized first. Let's polarized first, Then next step will be that it will be aligning positive and negative poles. Okay, positive, negative, they will create pole and it will be aligning properly. They will be coming together, poles will be coming together, poles will come together. Collide, okay, and coalesce. Now you are giving AC voltage, AC or DC voltage. AC voltage, what will happen? Particle will be vibrating. Particle will vibrate. When two particles are vibrating, there is greater chance that they will be colliding. And if you are giving DC, so particle will be pulled. Will be pulled towards electrodes. Okay, and when you are applying high voltage, particle will be distorted. Particles will get distorted. Okay, so high force will be coming if you are applying very high voltage. Okay, so if you see E square term is there, so that means if you are applying very high voltage, your force will be also very high. So electrostatic coalescence, also called coalescing filter. Okay, so this is also called coalescing filter. Coalescing filter or filter coalescence, coalescer, filter coalescer. Okay, so coalescence means coming together or agglomerate. Water molecule in oil, polarized water particle as dipoles. Okay, water particle will create dipole, plus minus. Okay, two poles will be there, one plus pole, one minus pole, with positive and negative ions. The dipole force is generated between neighboring droplets pressing together. Okay, so what they do in electrostatic coalescers, it polarizes individual particle, then it will be moving to each other, then it will try to squeeze together. It will be polarizing, then it will be trying to squeeze together. So then when they are squeezing together, in between the layer, thin layer of chemical, so that will be getting reduced. So it will be much thinner. After a certain time, the thin layer will get broken and they will be fusing together and they will make bigger particle. So this way the electrostatic coalescence was. So it will not change any viscosity or density, anything, just it will make bigger particle using high voltage of electricity.